Welcome everyone for the seventh session of Bayesian reasoning, the new science of knowledge at the new Center for Research and Practice with the instructor and Longo. I'll pass the word to Anna.
Hello, welcome. So today we have two presentations. We were supposed to have three presentations. So Amy told me that she cannot present today. She had some personal issues. I don't see Paulina. Maybe she will come later. So John, is up to you about this paper that you proposed to discuss. I'm very happy that you decided to share this paper with us. Really interesting one. So please.
Right. I'll start by saying I really regret that Dilshad is unable to join us today. I was really looking forward to him giving me a very hard time. So someone else will have
Maybe it's late. Maybe we'll come.
He's had a family issue.
Okay.
He wrote me. So someone else will have to give me a hard time.
We will try.
I chose this Paul Meehl paper in part because it's one of a set of discussions that's starting to take place in the 1950s at the same time that utility theory is being formalized by Savage and Friedman in the way that we looked at this week. So it's also the moment that Egon Brunswig is developing a lens theory of judgment that will develop into models of ecological rationality. It's also the same moment that Herbert Simon, another psychologist, is putting forward the notion of bound rationality. But Meehl's work especially has an outsized influence on Tversky and Kahneman. Kahneman says it's his formative intellectual influence. And as Anna noted a few weeks ago, over time, the line of thinking that comes out of this work will lead to behavioral economics that ends up trumping and displacing the kind of Friedman's sort of rational utility theory in contemporary economic thought, at least to a large degree. Meehl himself is also an interesting character that a lot of philosophers wouldn't have come across, but he's a Freudian-trained experimental psychologist who goes to Minnesota for his PhD at the period of high functionalism, so complete elimination of internal mind states for the study of behavior. But he becomes a kind of protege of Feigl, and through Feigl becomes very close with Reichenbach and Carnap and the logical positivists who settle in the United States after the Second World War. So he's really interesting in that he's a clinician and an experimentalist. But if you read his work, he also has a very good grasp of logic and is really quite interested in the philosophy of logic as it bears on psychology. I also think the question of where clinical judgment lies in these broader discussions is historically important and ethically important for this reason. If you look at the early 19th century, it's around clinical judgment that statistical models are most strongly resisted in science, especially in France. Hacking talks about this at some length in Taming of Chance. And the resistance of statistical models by clinicians is an ongoing theme over the last two centuries. So it occurs in a major debate over evidence-based medicine in the later 20th century. And today, one of the principal areas for the discussion of AI ethics, of course, is the integration of AI into clinical contexts, which again raises this question about the relative merits of human expert judgment and machine judgment. So there's an entire field of ethical and political questions about the relationship between algorithmic judgment and human judgment that becomes particularly concentrated at that moment when a doctor versus a machine is making a decision about a human beings' health. So I just want to go through one of the studies that Miel talks about to kind of ground what I say later very concretely, which is a study over the differential diagnosis of ulcers on a stomach, X-ray. So 9 radiologists are given 96 cases, which are fictional or composite cases. First, the radiologists are asked, choose a task at which your judgment will outperform a linear model. So the task is actually chosen by the radiologists themselves, and they identify differentiating cancerous from non-cancerous ulcers on the basis of X-rays. The clinicians themselves give the 5 Boolean variables, so yes or no variables to be tested, and there additionally is one 3-valued variable. So it's a case where the physicians are providing the variables that are then codified in a simple linear model, and then the physicians are compared against the linear model. The physicians are asked to rate 192 cases. In reality, it's 96 cases, each of the cases given to them twice out of order to test on consistency. And they do so on a 7-point scale between it is extremely likely that this is a cancerous ulcer to there is no probability that this is a cancerous ulcer. So the result was that 90% of their response was modeled perfectly by the simple linear equation based upon the criteria that they gave. Between the physicians, inter-physician agreement was 38%. So in 62% of the cases, their judgments conflicted, and their inter-judge agreement, their own agreement with themselves, was on average 80%, ranging from 30 to 90%. So a pretty significant period of time they're conflicting with their own judgment when given the exact same X-ray. So the conclusion drawn from this is, one, when they are accurately predicting, they are following a simple linear model rather than some kind of more complex nonlinear configural judgment, and that both interjudge agreement and interjudge agreement leaves quite a bit to be desired. So this is an example of Miel's comparison. And in the recent survey I found, there are roughly 200 studies along these lines in which algorithms show significantly better outcomes in 60%. And in virtually all of the other studies, the algorithms and the human judge draw are equal. In Kahneman's concerns, these comparisons are most vivid in low validity environments. That is, environments in which prediction is around 30% in general. And these are the environments in which algorithms consistently outperform experts. And these include environments like academic success, bankruptcy, longevity, myocardial infarction, neuropsychological diagnosis, parole violations, psychiatric diagnosis, and violence. And Miel's comparison makes 2 assumptions. First is that the model and the clinician have the same information. So this is really about how existing a set of information is combined. And then secondly, the models have to be corrected for overfitting. Otherwise, that will lead to the models performing worse. So why does statistical prediction win? And now, of course, there's a 70-year literature arguing about this, but I'm going to draw these answers from the 1993 article that I suggested. And the most straightforward reason is that even simple linear regression is calculated to account for noise, whether it's unknown factors or unpredictable factors, because in the least the least squares method, you're incorporating error in your estimation. Where human judgment abstracts from the possibility of noise. By and large, when we make a judgment about a future outcome, it's based upon what would happen if there was no extraneous or unpredictable event interceding. Linear models tend to be insensitive to differences in weighting, whereas humans tend to significantly overestimate rare possibilities and underestimate high likely possibilities. So in the kind of judgments that these studies are talking about, what this looks like is we're given test scores and grade point averages to predict college performance. And two applicants have equally high test scores, but some differentiation in their grades. And typically what tends to be found is that excessive weight is given to the small differentiation in the grade point average, rather than recognizing that the high correlation in the test scores means that there's no real difference to differentiate in terms of prediction. Another thing about linear models being insensitive is it actually turns out that in a lot of cases, imperfect linear models, or linear models where you simply randomly assign the weightings, do better than human prediction. So a well-fitted linear model outperforms an imperfect linear model, but a linear model where you just put 0.25 weighting on each of 4 variables still tends to outperform human beings consistently. Models are immune to heuristics such as biases or inconsistencies. So you're always going to get the same answer when you feed in the same information. And I added the final one, which was not in the article, because I think it's interesting from the point of view of Bayesian reasoning, but that actually clinicians consistently make use of extraneous information, even when they can identify the relevant variables for prediction. So even when these radiologists say there are 7 significant variables, they still add additional environmental information to their judgment, when if they eliminated that and stayed with the variables, they would have better predictions. So this entire question of where to cut off what we integrate into our predictions is really interesting in terms of actual human behavior. So from this, I'm going to kind of fast forward and take 4 things out of where I see this literature as having ended up that I think are relevant to some of the discussions we've been having over the course of the last couple weeks. And I think the meal debate ends up in models of empirical reason that are bounded, domain specific, and are inconsistent. And the most interesting outcome to me, I'm drawing really from work on modeling done by the Santa Fe Institute around complexity, which is that optimization depends upon the nature of the system, right? Equilibrium equilibrium can only happen in systems where there are rules that all agents can learn and then act on those rules. That's not possible in random systems by the very nature of their systems, because there aren't rules that can be consistently applied. And it's much harder in truly complex systems, which are often only locally discernible. And many systems are, of course, cyclical systems that oscillate between states of equilibrium and non-equilibrium. But the possibility, this sort of expands domain-specific rationality into a general principle. The possibility for successful induction depends upon the kind of system you're in. And if you're in a truly random or complex system, the possibility for successful induction simply doesn't exist by the nature of the system. I have Tversky is more of a rationalist than Kahneman, and in that sense, I often find him more useful. While people are capable of generating normative expectations, they frequently rely on intuition or heuristics in those contexts where the application of criteria is not immediately apparent. And Daryl and I had something of a back and forth about this a couple of weeks ago that I think was inconclusive. The argument here is that not that people aren't capable in some circumstances of developing highly powerful and accurate norms. It's that they're not actually often good judges of when those norms apply and when they don't apply. And when it's not clear, they often revert back to intuition, which can be accurate, but only in highly specific interests. Humans regularly violate the core axioms of expected utility theory and probability theory, especially extensionality and consistency. And though it's more contested, I would say transivity. And humans are routinely mistaken or unaware of the processes that underline their own particular judgments. Now, this body of evidence is often used to draw general skeptical conclusions, which in a lot of ways, which doesn't really make sense to me. And I pulled out a kind of summary of this research from a recent article in Nature by David Leslie, which characterized it as a holistic contextual understanding of reason that has led to a humble acknowledgement of the existential limitations of intelligence itself. The fact that these limitations were discovered through empirical exploration, that these limitations can actually be quantified, and the fact that these limitations can be corrected for by simple models that human beings generate, to me doesn't lead to generally skeptical conclusions about the powers of human reasons. It leads to general skeptical conclusions about the accuracy of individual human judgment in particular contexts. But that's quite a different question. And that seems to me very much related to the emphasis on learning process and collective rationality that underlines much of the motivation for some of the Bayesian models that we're looking at. So to bring this back to Bayes, and I won't read this long quote from the article, but of the reasons I chose Miel is that he brought Bayes' formula into psychological testing in the 1950s to begin to correct for the kind of base rate errors that were occurring in standardized psychometric tests. But Miel's attitude to Bayesianism is interesting to me in that he's a strong espouser of Bayesian statistics without accepting a general model of Bayesian rationality. And at the end of the article I suggested for this week, he suggests combining Bayesian statistics with dummy models. And what he means by dummy models is we know a common argument for why human reason is superior to linear to algorithms is that humans can learn from feedback and update their conditions. Miel notes that you can just introduce a dummy variable into a linear equation that's specified for the point of optimum prediction and then tracks how far the equation is from the conditions of optimum prediction. But he suggests folding this linear equation into a Bayesian framework where Bayesian conditionalization is used in order to determine the conditions under which the dummy variable is updated. And he asks, does this simply introduce human judgment again in such a way that it kind of throws us back to the starting point of statistical and clinical prediction. And he says no. And his argument is interesting, and it's that what the Bayesian framework does with the particular model is get us to step out of an inside perspective where we're viewing the judgment from the perspective of the agent, and to adopt an external perspective where we're viewing the judgment as one instance of a set of similar judgments, and from the external perspective, therefore weighting the character of the prediction problem. So it's not really using Bayesianism as, well, it's definitely not using Bayesianism as a description of actual decision, nor is it exactly normative and ideal to which we should try to aspire. It's more like one working model of decision making that can reframe the problem of an individual decision so that it's no longer being formulated from the point of view of the particular decision maker within a bounded context, but instead reframes the decision in such a way so that we're making conscious and rational decisions about the parameters we assume vis-a-vis other models of the same decision. And that leads me to kind of my final suggestion, which is, which is the possibilities of a Bayesian epistemology might in part be determined by what I would describe as a kind of primitive philosophical attitude towards formalisms themselves. And I mean something by this less coherent and less consistent than an idea like foundationalism or pragmatism or mathematical Platonism. But I mean almost the psychological tendency that people have when confronted with a highly effective and powerful formalism, to desire that the certainties of the formalism somehow transfer onto the phenomena that the formalism is modeling. I think we really see this in the history of debates over things like Gödel's theorem, where there's almost this deep psychological desire that at some, not just to test how much weight a formalism can bear, which makes sense in any treatment of a model, but at some point for the characteristics of the formalism itself to translate almost by kind of osmosis. And I would contrast kind of with a nod to Reza Negarestani's blog on toy philosophy, but even more influenced by arguments about the utility of multiple models by the Santa Fe Institute, which has done a lot of work showing that there are extremely good mathematical reasons for preferring multiple models to single models in context of complex situation. So I would contrast a kind of desire for formalism to serve as a scaffolding to an attitude of formalism that's more like playing with toys, and an understanding that you can pick them up, use them for the limits of their possibility, fold them into each other, just like Mill just did, look at them in comparison, model the strengths and limits of different kinds of model, but also not take them too seriously. And I think this kind of basic, almost attitudinal difference between formalism plays out in different versions of a Bayesian epistemological project. That's it, and thank you for your time and patience.
you very much, John. It was very good presentation and a very interesting topic. And I think that you had really pertinent insights and reflections. So I was interested in this thing, which is really important that you said about this kind of collective intelligence or the power of this collective reasoning, which is really important actually in Bayesianism in general, in the sense that, you know, there are these kind of markets for bets where actually I propose people to bet on future events, like the future president of the United States, or the probability likelihood of a war, of a terrorist attack. And they just observe the bets and they use them to predict events. And usually the people prediction are really, really good, in the sense that they rely more on these people predictions, like the average of a people prediction, than other systems. So maybe the machine for diagnosis, the artificial intelligence, trying to make decision for patients, is just enjoying this collective knowledge, because it's programmed with the knowledge of all the scientists, of all the doctors, and so it's kind of using more advices than the one of just one person has maybe a limited experience. And so this is really interesting. On the other hand, we also have the examples like Dr. House, where the case is so special, is so unique, that you need to explore everything again. So you cannot use a model which exists, but you have to invent a new model for this specific kind of new case. So I would like to know, if you know, just a curiosity, if machines are only collecting predictive models from scientists, or if they are also able to explore data and to produce new kind of hypotheses that were not in the set of the most used methods.
Yeah, most of these classical studies were done before like contemporary machine learning. And, you know, of course, now unassisted learning can produce these types of linear models extremely, you know, very easily. But still, you know, depending, it's sort of still ultimately bottoms out at the quality of the data set. I think to your first point, you know, there's a long tradition of mathematical modeling of juries that shows exactly the kinds of things that you're talking about, that that jurors collectively make better decisions given certain conditions than individual jurors. Sorry, I lost my train of thought. I'm just going to pause and give maybe other people a chance for a question. And I want to think about this issue about probability, like induction of rare or unique events, and how it relates to the way in which algorithmic models are generated in terms of clinical prediction. I think that's a deep question, and I don't have a off the top of my head answer to you.
So just to complete the list of the arguments against, you know, like you say, people say, okay, I don't want to be substituted by a machine because I am a doctor and I can do things that a machine cannot. But I think that maybe today the technology is so advanced that it's possible also to produce new hypotheses. So it was a question about the state of the art of the But if anybody has some question, please go ahead.
Hi there. I don't have a question proper because I pretty much second all that John exposed. But I was curious about as to what John does think that Dilshat would have objected to. I don't know if this is asking too much of you to debate yourself. Thanks anyway.
So one potential rejoinder is that a lot of this hinges on linear prediction, and that in most contexts, people are making what are called like fast and furious heuristic predictions that are nonlinear based upon even less judgment. And so if you take time into account, you don't necessarily have the resources to generate or figure out a linear model. But people make nonlinear, maybe abductive decisions in really complicated situations, and actually tend to do pretty well. Emergency room docs save people's lives. Firefighters navigate, which is a really classic example from the literature. That's why I'm drawing on it. Firefighters navigate houses, get people out, and rarely die. So that's certainly in certain sorts of pretty complicated situations, people make split-second nonlinear judgments that prove to be highly effective based upon a lot of experience. And so the tension has been between understanding these situations where expert judgment seems to fail more often than non-informed judgment. And those are the situations that Kahneman talks about, low validity situations. But what are these other kinds of situations, like an emergency room, where emergency room doctors in very short periods of time, yes, there's a differential diagnosis, but within that differential diagnosis are like split-second decisions that are often nonlinear in nature, and they fail sometimes, but they succeed an awful lot of the time. So people who like stress the latter kinds of instances think that the literature I surveyed is overly pessimistic and skeptical in the conclusions that it draws, because it abstracts too much from actual real world decision making contexts. That would be one answer.
Yeah, thanks. I wouldn't. Yeah, I think what we need is to complement those studies with at least that's something I'm curious about different perceptions of time, because temporalities here in case of the in the case of the emergency room or the firefighter navigating a house on fire on a hunch. Well, my hunch is that most of the times these people making this kind of decision and have a different perception and lived experience of time. They're living a lot more time inside 5 seconds. So I think they're computing a lot more of all these uncertainties in less time. I think temporality would be a good avenue of research to complement our status as decision makers when compared to machines. Thanks.
Other questions, comments?
Unfortunately, I missed most of the paper and the talk because of bad internet connection. I dropped out and I had to come back in. So I missed a lot of it. But a question that I had is about these intuitions or these scenarios when human beings are apparently much better in decision making that we were talking about, that you were talking about. What we are talking about here, just not human as in a being opposed to a machine. No, a human is a nervous system that's been a produce of so many ways of heuristics, actually decision making. So learning is very much in a Chomsky-esque way, is very much innate in an organism than a machine. So the point about the scaffolding or abstracting a complex situation into a formalized situation is, of course, a point that we lost some information, some relevant information. And I think that was your point about con-raisers, if I'm not mistaken. I thought about it a lot, but I didn't, I'm not sure if I understand it correctly. But to conclude, these scaffolding or abstracting, is there any other way? Is there any other way to understand ourselves as quote unquote rational being, apart from these kind of abstractions? Because the complexity or undecidability seems like an explanation that can explain everything that we don't know. So about these situations, I'm curious, as Friedman puts it, I'm curious that how we decide that this kind of interaction with the environment is human, and this kind is machinic or something like that. And yes, I understand the point about linear, and of course we do not reason linearly as in our semantics. Actually, I think part of our laws for reasoning is in the meaning of the words and sentences in our semantics. So part of the machinic practice has been already done by the history of the semantics. So we have so many histories and heuristic machinery that is being converged in an organism named human. So I think the comparison doesn't, I don't understand the comparison. I think there are two different things, completely different things. I'm not sure if I'm clear. Thank you.
Yeah, I think you're very clear, and I agree with most of what you said, Armand. I think part of the point of the radiology study I talked about is to show that actually these radiologists thought that they were making configural nonlinear judgments. In 90% of the cases, their judgments could be simply modeled by a linear weighting of terms, that we're actually making linear judgments far more often than we think we are, that people think they're nonlinear, holistic configural thinkers, and that's actually rarely the case, one. And two, when it is the case, it actually tends to make much worse predictions than if we simply were linear thinkers. I think for this literature, Miele's concern is not immediately a philosophical one, and more just simply what should we rely on in a given instance, making a given decision with a given amount of resources. Part of what's philosophically interesting is that the literature is extremely consistent about the consistency, the equality or superiority of linear models against nonlinear judgment. But the resistance it's produced in terms of the scale of cultural resistance is quite extraordinary. That we have this deep-seated fear that this thing that we create, so I agree that it's a false dichotomy, this thing that we create, which is a machine, decides as well as the creator in some circumstances, obviously produces this deep and profound, almost species existential fear. But what I like about what you said is how that's based initially on false dichotomy between creator and created that relies on disappearing the incredible power of evolution and producing the underlying calculating machinery that we use even in abductive and fast and furious judgments. No, I thought that was very elegant. Thank you.
I also think that could be pertinent to consider, for example, the game of chess. So machines are better than us in playing chess. But this is because the game is really framed in the sense that a human chess player is basically applying a procedure which can be formalized, in the sense that what you need is to calculate the probability of possible states of a game, future possible states of a game, given the present situation. And you have a kind of tree of probabilities. And that's what you have to calculate. And of course, a machine can do this better than a human, because it's just computation. So if we give to a machine a problem which is already solved, in the sense that you provide the procedure, the machine can do this better. The problem is that not all the problems are framed as a game of chess. So if you frame a problem of diagnosis, for example, as a game of chess, so we provide the machine all the complete list of symptoms to predict what the illness is, the machine will perform it correctly because it won't forget any of them, and it will compute exactly the probability, maybe better than a human. The problem is that sometimes we don't have a complete list. The list is probably uncompletable, so we are not always dealing with problems which are like games of chess, you know. So humans are able to maybe solve problems which are not so well framed in a better way than machines. But when the problem is well framed, so it's really formalized, a machine do this better because it's became a sort of mechanical thing.
And we often don't know what kind of problem we're trying to solve. And it's the point about rationality being specific to different kinds of systems. And we know that machines are also extremely good at discovering false false correlations, right? With a given sensitivity of analysis in a large enough data set, you can find massive numbers of correlations. But if it's truly a random data set, those still are all false. So they're in certain kinds of in random systems and certain elements of complex systems, neither a machine or a human are going to do fairly well because there's no underlying set of rules to discern, right? And so a lot of this is like, it kind of begs the question of when and how are we capable of recognizing the sort of system that we're operating in? And my strong, my take is that we consistently overestimate the regularity of the systems that we're operating within because of a kind of confirmation bias. Our incorrect judgments don't produce negative responses, and therefore negative consequences for us. Therefore, we assume that they're correct judgments. Therefore, we think we're operating in more ordered systems than we actually are. I think that's like how many people operate in the global economy. So if you don't have an answer to that basic question, the nature of the system that you're operating within, then you're right, you can't even accurately frame the problem to begin with.
Yes, exactly.
If anybody hasn't any directly related question, can I ask an almost unrelated question?
Sure.
Okay. About the point you were saying about the complex systems and the impossibility of predicting them, or what we should have, what we should cling on to be able to predict them. Something that always bugs me is patterns, right? Our patterns. Patterns are very interesting thing in a very morphological way. You see, there is almost a sci-fi narrative, but I think it's true. I can't find it online. I don't know exactly the source right now, but the story goes like this. So we have a colony of bacteria, or if I'm right, if we have a colony of bacteria, and we have a map of Tokyo and surrounding of Tokyo, and the area surrounding of Tokyo. So we abstract some distribution of resources in this map, and we distribute other resources, bacterial related, like this map, to these bacterial colony. And the shape that bacterial colony takes after so many generations are very similar to the shape of the city Tokyo. So this is mind-blowing, right? For me, actually, this is mind-blowing. This is so beautiful. So there are, even in the most complex pattern, even in the most complex systems, there are patterns that repeat themselves, even because otherwise they're just chaos. So complexity is the repeatability. So this repeatability is a possibility for prediction, or suggests the possibility for prediction. But to study this repeatability, what should we base our abstraction on? You know what I mean? Is there isomorphism? Is there, for example, Mandelbrot? Do you know how Mandelbrot thinks? So it's very interesting, his way of thinking. Sorry, I'm going on and on. But, that's what I know. There is a bit of a hyperstition, right? But it's very interesting. It's very bugging.
Yeah, and I might have misspoke, Armand, which is prediction's impossible in random systems. It's not impossible in complex systems. It's just very hard and often local. But that's also the argument for combining multiple models. It's almost a characteristic of complexity that it's irreducible to a single model, and which I think reframes the discussion of Bayesianism in a somewhat different light. If we're not asking, is Bayesianism the master model that's finally going to unlock how we reach scientific convergence, and rather think of it as a powerful model that we can use in combination with different kinds of models that allow us to get at certain kinds of complex systems. And that's why I wanted to end on there being a kind of fundamental attitudinal difference with regards to how we relate to formalisms, precisely because it's a question of, do we lock ourselves into one toy universe because of philosophical investment or professional ego, or the seduction simply of the simplicity, which I think is really at play. The beauty and the simplicity are very, very seductive. Or, you know, are we promiscuous in our philosophical models in such a way that can be adequate to complexity locally?
Okay, so I think that if you don't have other questions about this, which is a really interesting discussion, we will keep on this later by discussing about economics, because, for example, you have predictions in economics which are made, so the same equilibrium, it can be predicted by using Bayesian methods and non-Bayesian methods, like emergency methods. So then the problem is, since the model is working, are agents Bayesians or not, since we get the same result? So there is also this implication of saying, okay, if the model what made is working, does this mean that reality is such and such rather than in another way? And so, yeah, so it's an interesting point. Anyway, I think that Paulina is here finally.
Hi, I'm so
Hi.
sorry. My computer was not working. I couldn't connect. And is it okay if I present the last, because it's still kind of very like it's not working perfectly at the moment.
Amy is not here for the moment, so for the moment she won't come.
Oh, she won't.
No. So.
Well, maybe I'm connected with my phone.
Okay.
Maybe I can.
Just try. If not, you can present later at the end.
I'm not sure if I can share the screen. Oh, maybe. Oh, yeah, I can actually. Okay.
Or we can do this without sharing the screen. Just you see the screen and we look at you.
Can you give me maybe 10 or 15 minutes to try to resolve this problem with the laptop?
Okay.
I just want to show the slides, and like I think it will be easier for me to present.
Okay, no problem.
Thank you. I'm sorry.
Don't worry. Okay, so because I don't want to start because I don't want to repeat what Pauline is going to tell about Savage, who I think is really important. Do you have any question about anything or comment about anything, past classes, doubts in your mind, whatever, or about your final essay, any kind of thing you would like to say? Yes.
Honestly, I'm really afraid that every time I broach the subject of time, I'm sounding a bit like a new age weirdo, because I'm not really sure what I'm talking about, and I'm afraid that it's way off the bat, and I'm sorry, but I'm needing some reassurance that this, in terms of this being or not an interesting subject.
No, but it's just really complex. So I don't think that there is just a straight answer for the issue of time. So it's problematic in the sense that when you have predictive algorithmic systems, it's like we are shortening the time, in the sense that the computation is really fast. So this is one problem of time. Then we have also another conception of time, which is connected with the fact that we are all thinking about knowledge, considering that knowing is predicting. So it's a relation to knowledge, which is knowledge of a future, which is kind of impossible. So I think it's a kind of very interesting twist in the way in which we conceive knowledge. So all the process of knowledge projection is oriented to the future. And another thing which I think is interesting is that this kind of future, which is predicted, is not really the future, in the sense that we are not predicting like following Newtonian natural laws. We are predicting the necessary of certain positions of the planets in 1,000 years, which was possible. but we are predicting really contingent things. That means that a prediction of yesterday is not more variable tomorrow. So what I do with the weather forecast of yesterday? Nothing. So we have also a production of knowledge which is oriented to the future, and most of the predictions are just valuable today, but no more tomorrow. This is another way of providing another view of time or another perception of time, because it's a knowledge which is a knowledge about the future, but it's also a knowledge about the future which is no more valuable in the future. We have to remake the predictions every day because conditions are always changing. And there is another way of conceiving time, which is the idea that knowledge is a process. So it's a kind of science incorporating the history of science. Usually we used to say that there is no science of science. Today with Bayesianism, we have a science of science, in the sense that Bayesianism is a sort of science about how do we produce scientific theories. It's a sort of meta theory. So the general part is the meta theory, and then you have the predictive hypothesis, but all the Bayesian part is to judge different hypotheses and to update this predictive hypothesis. So it's a way of conceiving science, not just like, okay, this is my perfect theory, and that's it. And I don't care about if it will change, but it's a way of conceiving already science as a process. And so this is another way of considering time in the situation. So I think that basically it's affecting the perception of time, or what time is, in many different ways. And any of this would take long discussions, I think. So I don't know what is the one you're the more concerned with, or maybe another one.
Yeah, well, it's the first time I'm going to try to articulate this loudly. So, well, I'm interested in in having into account the possibility of the inexistence of time.
Okay.
Then I'd be left with history to treat analysis of probability, or I would be left with history to treat any matter. So yeah, I think that would be my approach, and considering history as a tool for navigating atemporally. This would mean history as something that fabricates states, conceives, or models states of the future. Yeah.
Did you read Carlo Rovelli's books?
No, but I'm guessing I should.
Carlo Rovelli, this physician, is working with quantum mechanics and relativity. So he's proposing this theory to unify quantum mechanics and relativity, which is the dreams of physicians today. And he wrote this book about the inexistence of time. So in order to put together quantum mechanics and relativity, is dropping the idea that time is real. And he has this really, is proposing this is called loop theory, loop quantum theory. And is based on the idea that space-time is composed by a sort of form of microparticle or quantum particles. So his conception is that time does not exist because the only thing which exists are just correlations. I just make you an example. Which is his example to explain why time does not exist. It was considering Galileo counting the oscillation of the pendulum to make these laws of motion, and basically he didn't have a clock, so it was just counting the time of the fluctuation with the pulses. This means that you don't need time, so clock is not measuring time. Clock is just a device with a regular movement, and you can substitute a clock with whatever has a regularity. So this means that we are just coupling different regular series like pulses and something else. So you can say the motion of a car takes 10 pulses to go from here to there, but it's not time, it's just a regular variable against another one. So just saying we can consider the universe like a mechanism where you have this kind of coordination, or you can measure a motion with another motion. So basically time is not time, but it's a measure of movement, in the sense that it's the same definition that Aristotle gave. For Aristotle, time is not time, but it's a way of measuring movement. In the ancient times, they measure time by the movement of the stars. It's kind of a way of measuring time, but we are not measuring time, we're just comparing motion with another motion. And any cycle is a count. We need regular cycles, and we can measure a regular cycle against another regular cycle. So it's not time. This is the idea. So the universe is just composed by these regular motions, and we can just compare one against the other in order to measure what we call time. So I think it's really interesting. You can find it translated, I think, in any language. It's called Carlo Rovelli.
Okay, thank you.
Welcome. I can send you the PDF if you like.
I would appreciate it a lot. Thank you.
Just remind me.
Okay. Thank you very much.
You're welcome. Paulina, you ready?
Yeah, I think it works now.
Okay, cool.
So I'm going to share the screen. And so I'm going to give a summary of the article on the decision theory written by Leonard Savage in the Foundation of Statistics book that was published in 1954. It's, from what I've understood, he was trying to outline the theory of a consistent decision in the face of uncertainty. And he tried to create a formal model of the decision process that the person is going through when faced with uncertainty. And so he introduces terminology and like, for example, the person is a highly idealized theory of the behavior of a rational person. And he suggests that we agree that certain behaviors of the person can be deemed rational to an extreme. And he also introduces the term the world, which, like, as you can see from this table, denotes the object about which the person is uncertain, as well as a description of this object, which he calls the state of the world. And the true state of the world is the actual description of this object. I think it will be more clear from the examples. So for example, the person can be uncertain about whether a certain egg is rotten or not. And in this case, the object the person is uncertain about is the egg, and then the world is the egg. And the state of the world, which is the description of this object, which is good or rotten. And this is an example of a small world because we have only one object and just two possible states of this object, meaning the world. And the second example is an example of a bit of a larger world in which the person is not certain about a particular dozen, is not certain about whether one egg within the dozen of eggs is rotten or not. And in this case, the world is a dozen and there are like 12 in like there are this, I'm not sure how to say it in English, there's 12 in the power of 12 states of the world. And the other examples he proposes are this that the temperature in Chicago at noon yesterday, we might be uncertain about that, and as well as the exact and entire past, present, and future history of the universe. And in these examples, there is an infinite number of descriptions which reach its ultimate complexity in the last example. The problem with this formal model is to understand which word to use in a given context. So he suggests that we might take the larger world of two worlds as a model for the situation. And there won't be any harm to that. So for example, is the only brown egg in a dozen rotten or not? Is an example. And we might take the larger world within this example, which is the dozen, as a model. But in the next example, the vagueness is like the constitute of this example. Therefore, we cannot really take the largest world as a model in this case. And therefore in the example of a small world that the brown egg is rotten, it is a description of this small world in its entirety, and it leaves, but at the same time it leaves much of the larger world, which is the dozen, undescribed. From this, we can conclude that the state of the small world doesn't correspond to the state of the larger world, and it corresponds to a set of states. And with this, he introduces event, which is a set of states. And he describes the universal state, which he denotes with the S, and it means the event. It denotes to the event that has all the states of the world as its elements, and we can conclude from this that S is the world. And the opposite of that is the vacuous event, in which the event has no states as elements at all. So the egg is both rotten and good. It's not possible, therefore it's a vacuous event. Sorry, I'm a little bit lost here, but and if the event contains the true state among its elements, he suggests we use a certain terminology, which is the event obtains. I'm not sure if what I describe at the moment really makes sense, because I don't really have the terminology to describe it, to describe the theory in its precise detail. But from here we go on into the section of acts, decisions, and consequences, and he identifies the decision. He identifies the acts with the consequences, and the consequences are what happens to the person. So they are the states of the person rather than the states of the world. And in order to make this process of making a decision by making an act and acknowledging its consequences, he proposes a formal model for that, in which he creates and makes a function out of an act, and this function attaches a consequence to each state of the world. And having all the acts in a given situation together, he denotes it as an F. So he proposes an example of how to make an omelette. And there are 3 possible actions. And that would be F. 3 possible actions is F. And the states of these actions could be, I would explain it in a way that, so I'm not sure if this is really, if this makes sense. In any way, I think that the main part of his article was it actually goes back to this question, which world to use in a given context. And he proposes an idea of 2 proverbs, one of which is to look before you leap in making decision, and he takes it to the extreme. So if one has to envisage every conceivable policy for the government of his whole life in its most minute details in the light of the vast number of unknown states of the world, and decide here now on one policy. So this kind of extreme seems utterly ridiculous and beyond human possibility to predict every possible consequence and following consequent act of this process, and contradictory to that proverb, he proposes another one, that you can cross the bridge when you come to it, which basically means to attack relatively simple problems of decision by artificially confining attention to a small world. So we go back to the look at before you leap principle. And in this case, as I understood it, he suggests that we can only choose the smaller world and make consistent rational decisions within the constraints of the smaller world. And from there he goes on into to introduce the formal reasoning of preferences, and he suggests that we, in order to understand what the person prefers between two acts, we should not ask question in regards as how the person how the person just feels about which act he or she prefers, but we should think about what the person decides to choose. And in order to formally present these relations of preferences, he suggests that we use the terminology of, for example, F is not preferred to G instead of G is preferred to F. So if F is not preferred to G and G is not preferred to H, then it is possible that F should be preferred to H. And he creates this kind of postulational treatment of the relationships of preferences and indifference. And in mathematical terms, it's this kind of relational preferences is known as the simple ordering. And this is his first postulate, and the theory can be interpreted as if F is a finite set of acts, the person will decide on an act H in F to which no other act is preferred. And from here he goes on to discuss the idea of personal probability, and he gives his preference to the idea of intermediate interrogation. So we can ask what the person prefers through a verbal direct interrogation, or by making an experiment to see the actual behavior and decision of the person. This intermediate interrogation implies that that we ask the person what she or he would do in such and such situation, instead of how does this person feel, like what is more probable in that situation. So I'm going back to to summarize this brief presentation. And I guess I'm not sure how consistent this presentation was and how logically consistent it is, but from what I've understood, he was trying to create a formal model for our process of the decision making when we are faced with uncertainty, and this theory, as he writes in his text, is used to check on our personal coherence of our personal decisions and to check how coherent our decisions are. But at the same time, he offers a critique of this theory as well, that the formal description of a decision can be inadequate in certain situations, and one of them is to is how can we apply this formal model within the large world, and this I guess this problem is still unresolved, but the main outcome from his paper is that we might apply this formal description when we deal with small worlds. That's what I've prepared for today, and yeah, I that's it.
Thank you, Paulina. It was good. Don't worry. It was good. You got all the important things, and the most important is really this discussion between large word and small words, and also this idea of look before you leap. So you got the important points that we're going to discuss further. So it was a good introduction to Savage, just because it was not so easy as a text. So thank you very much.
Thank you for listening.
So I think I will start talking a little bit more about Savage, connecting it with development in orthodox economic theory, and then the discussion about the rational agent in orthodox economics, if you don't have any prior question. Okay. So Savage's foundation of statistics is really important, because he was really the person who introduced Bayesianism in the United States, and in particular, he developed the decision theory and the model of the idealized rational agent, which is the ground for all orthodox theory in economics. So usually Bayesians say that you cannot make the omelette without breaking the Bayesian eggs, and this refers to this very famous example of the omelette in Savage. It starts by saying that it's theory for making a decision. So it's basically considering Bayesianism connected with decision theory. So it goes back to Ramsey, and we saw that Ramsey had this very pragmatic view of Bayesianism. It goes back to Ramsey also because he thinks that the most important thing to consider in order to judge the coherence is the ordering of preferences. So as Paulina told, we have these preferences which are well ordered. So preferences are ordered, and what is important for an agent is to know to be coherent with respect to the preferences. It doesn't matter what the preferences are. What is important is that they are well ordered. And we will see that this is really important for the economic theory. And this idea of the ordering of preferences as a criterion for coherence is coming from Ramsey. Other thing which is important to know is that, well, they are quoted many times in the paper, but it's just not discussing them very much, is von Neumann and Morgestern, which is this book, Game Theory and Economic Behavior, which was published in 1940. And they introduced this idea of the utility function, even though they didn't call it utility function, but they introduced this idea of a game theoretic framework. So decision theory is basically working in a game theoretic framework, and it's what you see more explicitly in the other readings, where basically agents are not just predicting states of a world, but they are predicting each other behavior. So the world, the environment of any agent is other agents. So any agent is the environment of any other agent. So they are just predicting each other behavior. And this is the game theoretic framework. So the attention is going to the model of rationality. So what decision a rational agent will make given a specific problem or a specific situation. And so this is important as a switch because as we saw, for example, in the other classes about artificial intelligence and also the Bayesian brain, the idea is to modelize how do we make decisions, how a rational agent makes decisions. And so this is the other side of Bayesianism. So we're not really concerned with the prediction of natural facts, but we are concerned with the method for predicting future facts. So basically, Savage is proposing one of the first model for the rational agent. And this is an hypothesis, as we said in the other classes. It's an hypothesis because, I mean, it's not just saying, okay, the agent is a Bayesian reasoner, but the idea is provided that an agent empirically will make some decision, what is the correct model to predict his behavior? So it's the same thing that models for in biology for the Bayesian brain are working. So they're not saying, okay, the animal or the system is Bayesian. They are just saying, okay, it's behaving in some way. How do we model this kind of behavior? So I produce a Bayesian model, and I see that this model is consistent with the behavior of the studied system. So I can say, okay, maybe the agent is reasoning according to a Bayesian procedure. And this is really clear in the text by Friedman. So Friedman says it's not important that it's realistic. We consider an agent as if, and he repeats with as if many times. So as if it was a Bayesian reasoner, as if he was maximizing utility. So the idea is not that we are implying a sort of realism, but we are producing a model to predict the behavior of an agent. And this model is based on the assumption that modeling the agent as a Bayesian reasoning is efficient in order to predict the behavior, and in particular, to predict the way in which decisions are made. And so then this problem of realism is very important in all the criticism of Bayesian rationality. In particular, the new heterodox economists, for example, are just saying, okay, but it's not true. Agents are not Bayesian rational decision makers. They are just using other rules for learning, etc. So this idea that the model is an hypothesis to predict the behavior is very important. So there is not an assumption about we are Bayesian machines, but the idea is we can predict the behaviors of agents as if they were by using a model implying Bayesian reasoning. So it's an hypothesis. It's kind of like toy model of the universe. We can have a model of the agent, which is made assuming that decisions are made according to Bayesian reasoning. And the only important thing is that it works, that it's efficient in predicting the behavior. So is criticizing, of course, first of all, in the first part, is criticizing the logic approach. And in particular, we have to remind that in economics, logic probability were supported by Keynes, John Maynard Keynes. So what is implicit in all this is a way of opposing Keynesian conception of economics, which is called normative, and to propose a positive economics. So this normative economics is based on the idea that we use logical probabilities, and the positive economics is based on the idea that we are inquiring empirically on the agents in the market. So we're not considering that there is a general theory of economics, like a sort of system made of variables like employment, inflation, and we modify the variable inflation, and we modify the correlated variable, which is employment, etc. They are dropping this kind of model, and which is based on logic probabilities, in the sense that there is a sort of prescription of sort of kind of laws of the market. So there are correlated variables. If we modify one of the variables, we can modify also the other one, which is related to the first one. The idea is to introduce a totally different model which is based on the idea that the subject of the market are these rational agents, that everything depends upon decisions, rational decisions. And this implies also that there is no planning which is effective. So one of the effect, or one of the goal, which is really explicit in Friedman's paper, Friedman and Savage, because we wrote that article together, is the idea that all these politics policy for reforming or for planning economics is totally useless because agents are rational decision makers. So behind all this, there is this critique of Keynesian theory of economics. So it's just re-explaining all this idea of the personal probability, so subjective probabilities that we already explained at the beginning, so there is nothing new about there. What is important, I think, is what Paulina said about the world and the states of the world and this function which is connected with the consequences of action. So in this you have all the theory of utility, of maximization of utility. So to go back to the idea of the omelette, which is really good example to explain. I'm trying to find little this idea of the omelette, which is the most famous example. So one has to make an omelette and he has 6 eggs. And basically doesn't know if one of the egg is rotten. So this is uncertainty. So the uncertainty is one of the egg can be rotten. And there are possible actions. And any action is associated with consequences. So for example, the best possible options or the best possible world is the world in which no egg is rotten and I have a 6-egg omelette. This is the best possible world. So my utility is maximized in this state of the world. So what I have to get is 6-egg omelette. This is the perfect, maximizing utility. The problem is that if one egg is rotten, I cannot actualize this state of the world, of course, because I have 6 eggs, but I don't know if one is rotten or not. So there are options. I can just say, okay, I don't care. I just put all the eggs in the bowl and I don't care. This means that the risk is to spoil the omelette. So I break 5 eggs, I break the 6th egg and is rotten. I put in the bowl and all the omelette is spoiled. So this is not a good decision because instead of maximizing my utility, I have a high risk of find myself in a less preferred possible state. This is why the ordering of preferences is very important. So I can find a way maybe to pay something in order to avoid to find myself in the worst possible scenario. So to do this, there is a solution, which is to break the eggs in a saucer, so to check if it's rotten or not, and then to add the egg in the bowl. So I will pay a little fee, which is I will have to wash a saucer, and also the procedure is longer. But it works because it allows me to have the omelette made with the maximum possible number of eggs. So the idea, so if I don't know if you see the table, there is this the example illustrating acts, states, and consequences. So you have this table where you have possible acts, which are break into bowl, break into saucer, throw away. And you have two different possibility that the egg is good or rotten, which is the uncertainty, what I don't know, and the possible consequences depending on the states of the world. So, for example, if I break directly the eggs in the bowl, if all the eggs are good, I can have a 6-egg omelette. If one is rotten, I have no omelette, and 5 good eggs destroyed. So these are the true consequences of action. So in order to maximize utility, I have a function which goes from the probability of different states of the world, so the egg is rotten or good, to the consequences of the action that I choose. So for example, if I choose the act break into the saucer, I can have 2 possible future situations. One future situation is 6-egg omelette and a saucer to wash, or 5-egg omelette and a saucer to wash. If I choose the action throw away, I have 5-egg omelette and 1 good egg destroyed, if it was good, or a 5-egg omelette. So it's very clear that the act that rationally maximize the utility is break the egg into the saucer, because I have the 2 options are the best. So the 2 options are 6-egg omelette and a saucer to wash, or 5-egg omelette and a saucer to wash. This means that both the states, the possible states, are the best. So if I choose this action, I'm sure to maximize my utility with respect to the outcome of the other decisions. So this is basically the decision theory. So when we talk about maximizing utility in an economic way, we are just considering that any rational agent in this situation will choose to break the eggs in a saucer. So we can predict the behavior of the agent in this situation, considering what is rational to do, what decision is rational. And I think that anybody will agree that in this situation, this is the most rational action. So the problem is that not all the problems are as simple as this one. So this is a description of a very small world, because you just have 2 states. The egg is good or rotten, and you have a limited number of eggs, like 6 eggs. You don't have to check like 3,000 eggs, but it's a small world. You have your 6 eggs. You don't know if one is rotten or not. And it's very easy to master the problem and to choose the most rational act in order to maximize the utility. So to increase the probability of enjoying the best consequences and avoiding the worst possible scenarios. So it's really easy, but what is important to notice is that conditions are really restrictive. So it works if we are in a situation as simple as this one. So this is a small world. So of course, in a small world, you look before you leap. And you can do this because you can manage the whole set of the consequences over states of the world. It's manageable. In larger world, this is no more possible, and we go back to the idea that we saw in Solomonff, where of course, if there are too many hypotheses to be compared, so for example, I have rather than having just two possible states, the egg is good or rotten, I start to have 1,000 possible states. It became really difficult to be computed. So the problem for Savage is that it's really easy to make a model of a rational agent in a small world when the problem is really well defined, but it's not really possible to model the agent in large worlds, in situation where too many variables must be accounted for. So this does not mean that it's not possible to take decisions in large worlds. It's just that we cannot really formalize how to do this. Then another thing which is important in Savage is the issue of convergence of beliefs. So it's clear that in the problem of the omelette, beliefs will converge. So any rational agent will make the same decision by knowing that one egg might be rotten. But of course, if we are in a large world, this is more difficult. So according to Savage, there is a tendency for convergence of belief, but there is no necessity for the convergence of beliefs. So this idea of look before you leap and cross a bridge when you came to it, I think. It's really important, and it will be repeated many times in literature. So if we had to look before taking decision by carefully considering any possible future states, any possible variable and contingency, we will never make a decision because it's too much. But of course, it's a good thing to do, since we know that we cannot really predict the future, and we should try to consider the more possibilities, and so there is a more practical way of doing this, which is just, okay, sometimes we don't have the time, we don't have the possibility of considering all the details because it will prevent action. So we need a more pragmatic way of deciding, of behaving, and this is the object of Savage inquiry. So in the second part of the book that you don't have is really trying to make a model for this more pragmatic way of making decisions. So I think this is the basic in Savage. So what is repeating is that the theory is important to predict the behavior of the others, and this is why it's really important in economics. So do you have any question about this? Okay, so I move on to Friedman. So there are basically two papers which are co-written by Friedman and Savage. This is the second one. The first one is about risk. So why this is important? This is important against Keynes. This is why he's insisting a lot about on risk. Risk is a preference, according to Friedman and Savage. The Keynes idea was that a rational agent would never make risky decisions. A rational agent will calculate. I don't know if you remember, but we said that according to Keynes, probability is logical implication between premises and consequences, where premises are the evidences and consequences are the predictions. This implication is based on a scientific theory. And the scientific theory is just logically constructed in such a way that there is a logic way or a true way of considering the probability of a prediction given some evidences. So it's normative in the sense that given some evidences, a certain prediction is logically implied and other predictions are not. We said that from this standpoint, there are a set of decisions which are rationally possible. So given some evidences, I have my logical consequences, so some predictions which are implied by the premises. But of course, there are things I cannot predict. So according to Keynes, there are situations in which I cannot calculate the probability of future events because there is no logic implication. So for example, I cannot predict a financial crisis which is provoked by an international war because I basically cannot predict or calculate the probability of a future war. So this any decision which is based on the expectation of a future war, it's a not rational decision. It's a decision where the risk cannot be calculated. So it's a decision in uncertainty. And according to Keynes, this kind of decisions are not rational at all, because I cannot calculate the probability in a logic way. So I cannot calculate the risk. So the decision is not rational. This, of course, implies that financial speculation is irrational. And also that there are very bad effects of financial speculation on the market. And they are kind of talks about animal spirits for describing this speculators taking decision based on really uncertain predictions. Of course, when we are in a sort of liberal market, we need to let all this behavior to be expressed. And so the idea for Friedman is that we cannot say that a speculator is irrational and that is just betting on uncertain things irrationally, guided by animal spirits, but is really calculating, but there is a high risk. And he can do this according to subjective probabilities. So a choice involving high risk is not irrational, but it implies the calculation of a risk, the calculation of a possibility of obtaining the desired state of the world. And there is also this idea that there is a preference for risk. So there are agents in the market who behave by taking fewer risks, and agents who are attracted by risk, but this does not mean that the first are rational and the second are not rational. The idea for Friedman is that even this irrational behavior can be predicted. So they do not pose any problem for economics, for the system, because they can be predicted in the sense that I can observe an agent who makes this kind of risky decisions, and I can tell that he has a preference for risk. So given a certain situation, I can predict that he will choose the risky option rather than another option. So they don't actually pose any problem for the market. It's just a way of maximizing a utility. So the hypothesis is that individuals choose as if they were seeking to maximize their expected utility, so the expected value of some quantity. And if one is happy with the thrilling experience of risk, this is not a problem at all. So all this idea is against, again, this logic theory of probability, this logic and normative, which is called normative approach, mostly in Keynes' approach. So again, the utility, as we said with the example of the x, is just the function which goes from the prediction of states of the world and the possible consequences. So I need to calculate the decision, which decisions allow me to hope to find myself in the best possible scenario while avoiding the worst scenario. So it doesn't matter which are the preferences. So any agent can basically prefer the states he likes. So there is no a norm about what should be preferred, and this is against the policy of social welfare, in the sense that it says in these kind of policies we are kind of saying, or we are forcing the agents to prefer something rather than something else. In this liberal theory, we don't know what the agents prefer. We just know that they will act in such a way to get what they prefer. So the idea is that we are not put limits to what should be the good for people. We just let them to choose what is the good for them, and we assume that they are rational. And by assuming that they are rational, we are sure that they will make the best decision in order to achieve their goals. Then, of course, he repeats that this is a scientific hypothesis that enables us to predict phenomena. So in this case, to predict the behavior of agents. Why is it important to predict the behavior of the agents? It's important because basically agents are predicting each other behavior. This is just part of the utility maximization of utility, just the first part. The second part is that any agent knows that any other agent is taking decision in order to maximize utility. So when we have to calculate the possible future states of the world, we are basically calculating the effects of other people's decisions. So in a market, For example, the tomorrow price of bread depends upon the preferences of agents. So if, for example, anybody will prefer brioche tomorrow, price of bread will drop. So if I have to make my decision concerning tomorrow price of bread, I need to know the preferences of other agents, so what they will do. And if I prefer brioche, of course, they will act in such a way to have more brioche as possible. So that behavior is predictable is not just because the economist wants to predict people behavior, but it's because behaviors must be reciprocally predictable in order for the market to work properly. So in orthodox theory, there is this idea that what the economist knows is known by the agent. So the economist, in this case, Friedman making hypotheses about future decisions of the agents, is the same kind of reasoning that Bayesian agents are making about each other. So economy works if any agent is able to predict other agents' decision in the same way as the economist is doing. So the economist is not knowing more than the agents. They all sharing the same knowledge. And this is really important because this is the strict condition making the big word a small one. It's a way of framing the problem and making rational decisions possible. Because all the agents basically know everything. So everybody knows what the other know, and everybody know what the other will choose or what the other will decide in a given situation, and anybody knows the situation. So there are no, and it's like they were playing a game of chess by knowing the rules. So it's really like a game of chess. It's called a fair game, and market in equilibrium is called a fair game because any agent has the same chances of winning because basically they are sharing a lot of knowledge. So both the players in a game of chess knows the rules. They know the situation, so they can look at the chessboard, and by looking at the chessboard they know the situation exactly. They have all the information which is needed to predict the decision of the opponent and to act in such a way to maximize the expected utility. So market in equilibrium is like a game of chess. But it's like a game of chess because the assumption is that there is agents are sharing the same kind of perfect knowledge of the game. So they basically know the state, the present state perfectly. They know the rules and they know what the other know. And they know that reciprocally, they reciprocally know. And so one can predict the possible decisions of the others and vice versa. Of course, this situation is really idealized. And so from this kind of idealization, we have all the criticism of the heterodox economic theories. So this kind of market as a game of chess is called the equilibrium. And the equilibrium is a term, of course, from game theory. So in a situation of equilibrium, any agent can play the best possible strategy with respect to the other agents. To play the best possible strategy with respect to the other, the condition is this kind of perfect knowledge of the situation, perfect knowledge of the possible future states of the world, and they both have to share this same knowledge of the possible future states of the world, like the possible future states of a chessboard given a present situation. And of course the rules and the preferences of the other agents. To know the preferences is very easy here, because by observing decision, one can deduce the preferences. So one says that preferences are revealed by decisions. Then rather than having a chessboard in the market, we have prices. So basically prices are the same function as the chessboard in a game of chess, in the sense that by looking at prices, I have all the information about the present situation, which allows me to predict the possible future states. Like in a game of chess, I look at the chessboard now, and I know there are kind of 10 possible future situations which can be developed from this situation, provided that the agents are rational. So if my opponent is rational like me, I can say that it will move in kind of 10 or 15 possible ways given the present situation. So in the market, we observe the prices and we say, okay, if all the agents are rational, they know that everybody else is rational, etc. There are just few possible future states given the present situation. So all the information is conveyed by prices, which are the same function of this chessboard in a game of chess. Of course, the problem is are prices conveying all the information which is needed to take decisions? So is the market a small world like a chessboard? So I think that the beauty of orthodox theory is just that mathematically is coherent and consistent like a game, in the sense that is really clear. The formalism is perfect, is beautiful. The problem is that it's a little bit too idealized to apply, in the sense that we cannot explain phenomenon like excess of volatility, for example. It's not possible to explain the evolution of the equilibrium, in the sense that once the equilibrium is reached, nobody has the interest to deviate, because to deviate means that I do something which is unpredictable for the others. And this means that I don't want to do something unpredictable. I shouldn't want to do something unpredictable, because I don't want the other to do the same. Because I prefer to keep the situation in which anybody can basically rely on prices to make optimal decisions. So if anybody are really believing that prices are conveying all the information, we will try to keep prices informative if they were rational in a situation of course, the reality is different. Because of course, when you are in a situation of equilibrium, it's not possible to evolve. So it's not possible to explain how the equilibrium passed from a state to another one. So as, for example, one can introduce new technologies and how conditions of production change and whatever. So in a situation of equilibrium, this cannot be explained. So other heterodox models are trying to explain this, considering that the market is not like this perfect game or a small world, but it's a large world. But of course, in a large world, we are not sure that we are able to make the decisions allowing to maximize the utility. So if the situation is really framed and all the information is shared and behaviors are reciprocally predictable, any agent can make sure to make optimal decisions, so to have the chance of maximizing utility. If these conditions are not met, it's very difficult, it's more difficult to really be able to compute the action which allows for maximizing utility. And so here you have the link to the other papers. So I think that Cristina Bicchieri's paper is really good to, it's really clear about all this problem in general. So this kind of idealized situation of equilibrium and the critiques which are possible. So of course, she says, in the ideal situation of the market equilibrium, of course, agents can make the decisions that allows to maximize utility. But of course, these conditions are maybe not real conditions, mostly because we cannot explain how do agents come to a situation of equilibrium, and this is the most important problem. So how the equilibrium is like, okay, in the orthodox theory, it's like the market is a game of chess. We are playing this game and we all know what we need to know in order to perform a good game. But of course, the market did not came out as a game of chess alone. So it was not just put in the world like a game of chess. It became a game of chess. So people converge to some rules in order to get the equilibrium. So the equilibrium is the result, or is the solution of a problem. And orthodox theory, of course, does not explain how the equilibrium emerged in the first place. In game theory, when you explain in classic game theory, which is the ground for orthodox economic theory, the equilibrium condition for the equilibrium is rationality of the agent. So the assumption is that agents are so rational that given a problem, they all figure out the same solution. So they agree or they converge to the equilibrium immediately by reflection. Which of course is possible if the problem is already framed. But we are in a sort of cycle. So we can do this if a problem is already framed, but we have to explain how do we get to a well-framed problem. So orthodox theory basically cannot explain how the equilibrium was realized in the first place, without assuming this sort of perfect knowledge just given. So yes, Bicchieri is like really explaining this very well, I think. And then we got to the last paper that you have by André Orléans. And André Orléans is really interested in heterodox economics, so he's studying the conditions for the emergence of equilibrium in the market, provided that agents do not share this kind of perfect knowledge. So the idea is to try to model the way in which beliefs converge in a sort of spontaneous way. So it's a model of the dynamic of beliefs where agents are not really predicting, we cannot predict each other's behavior, but probably where we converge to a situation where that can be considered as an equilibrium. Of course, maybe not the optimal one, because as you saw, many equilibria are possible. But his paper is a way of showing how the equilibrium can reach in a situation where agents do not share this kind of perfect ideal knowledge. So I think it's really interesting to see its dynamics, which are determined by mimetism. So it shows these information cascade, which are really interesting phenomena. An information cascade is, for example, what happens. So imagine that you are in a place that you don't know and you have to choose a restaurant, but you don't have any information, and there are two restaurants in front of you. One is crowded and the other one is empty. Which one you choose? Of course, you choose the one which is crowded because you think that if it's crowded, it's because it's better than the other one. So information cascades function in this way. So people who doesn't have the information, doesn't have the time to get the information which is needed because it's costly. They just rely on other people's decisions. And of course, the first to choose the restaurant maybe had a reason to do this, but most of the people who came later, they did not. They just imitate the first people, thinking that they had more reason or they had right information to make this choice. So we can model phenomena in the market in this way by considering that there are imitators and mimetism, which is a rational mimetism in some way, because I don't know, so I prefer to rely on the decisions of people I think are more informed. And as you see, there are strange dynamics which are produced depending on some parameters which are observed. So you can have chaotic results, you can have very strict equilibrium. The fact is that the agents themselves cannot really predict what will happen when they make their decision. So they're not sure to maximize the utility. Okay. So I stop to answer your questions or comments or whatever you want.
I mean, I have one thing that it's, I mean, I'm sort of thinking it out loud because I'm not sure on it yet, but I was just thinking about the most recent example, and it seems to me that one of the, it seems that it's suggesting it is not necessarily always rational to act in this kind of mimetic way. And the reasoning for that, it would presumably be like, you know, because there's something about the substantive matters at hand, right? Like the quality of the food in the restaurant or something is what really would decide what was a rational decision. And wouldn't this, in that case, be in kind of contradiction of, or in like, wouldn't that be in tension with the idea that personal probability or subjective probability, its criteria of rationality is not substantive, it's just purely formal. I mean, maybe it's supposed to be in that kind of a tension, or maybe this is kind of like a false tension that I'm just, you know, I haven't fully thought through, but I was kind of curious about that last point. Yeah,
no, I see. I think that the problem is the word, the dimension of the word in which the agent is, in the sense that for the problem of the restaurant, if it was a small word or like a well-framed problem, you would have all the information that you need in order to make your decision according to your preferences. So in this sense, given all the information, you can be sure to make the decision that maximize your utility, whatever it is. The example in Orléans is an example of a large word in the sense, so it's not in Orléans, but it's like similar to, it's in a situation in which you basically don't have information. So you can just guess and say, okay, according to me, this restaurant is better because it has red flowers outside, and I prefer red flowers, or I mean, red remind me of good things or whatever. You can have your subjective probability and just choose. But in this case, it could be rational, but maybe it's more rational to rely on other people's choices, considering that they are rational. So you don't have any information. You presume that maybe others have information that you don't have. So in this case, it's rational to rely on the decision on other people, assuming that maybe have information that you miss. Of course, this not guarantee that you will maximize your utility. But the problem is that in large words which are not perfectly known, the maximization of utility is not possible. One can make better and worse decisions, but optimal decision is under the condition of a really framed problem, like the problem of the egg, of like a game of chess. In other situation, no. So the idea, I mean, if we are really objective in the considering rationality, we can say, okay, this imitation is not rational. If we are considering rationality like a practical way of reasoning, it's rational. It depends on the definition of rationality. And this is another problem of a theory, in the meaning that rationality is sometimes this kind of perfectly idealized model where agent maximize utility. So if it does not, it's not rational. And sometimes rationality is just this practical way of dealing with problem when we don't have all the information which is needed in order to make optimal decisions. So there is an ambiguity, but the problem is that rationality is defined in different ways according to different theories also.
So one thing that I found interesting in Orléans was another paper that he am I right? That he wrote on Foucault and liberalism. I don't know if you read that. That was a brilliant paper. So there, he actually talks about exactly this notion that you were talking about in the last sentence, that this rationality is actually the result of a scientific movement in the 18th century, in a Foucaultian way, right? Is the result of a movement in an 18th century scientific movement that tries to look as subjects as natural, not slaves of God, I don't know, creatures of God, or creatures of, or subjects of kings, none of that, but natural. So for nature, for us to be natural, again, in a Foucaultian sense, the power needs to abstract something that can be observable from us that are named subjects. Here we talked about interest, our interest, right? Something that was interesting in Orléans' paper that we read with each other was that there actually he talks about when, I don't know, maybe it was not Orléans, but when there is no possibility of knowing that any as it were solipsistic point in markets are what he's doing or she's doing and the problem becomes interactive between two subjects, then interest is not so much a good, how do you say it, a measure for knowing subjects. Subjects are just how they pursue their own interest. If we think about it actually in a complex way, and we think about it in all these undecidabilities and all that we talked about through the sessions. If we think about like that, then we cannot think so lightly about interest, as if we know what interest is. The interest, a very abstract way for a solipsistic subject, I think. And the term herd opinion, that was a very interesting Nietzschean, Foucaultian term to use for those kind of decision makers. I think the term rationality is hard to apply here to a decision making like that. Of course, if you don't have any other information and you must choose between two restaurants, I agree with you. You should definitely go to the restaurant that more people are there. But that's not a basic, that's not so good, that's not a basic pattern to, I don't know, to see all the decisions like that. That's how I understand it. But and a question, I have a question. What do you think about the value systems, about economic value systems that we have today? Basically, the wage value or the labor value system or the price value system that you talked about or Friedman talks about. What do you think about other value systems? Because I know very little of them. I would be interested if anyone had any ideas. Thank you.
No, I think that both the perspectives are problematic, in the sense that this idealized orthodox theory basically is theorizing a fair game, where anybody has the same chances if they are rational according to the strict, strong notion of rationality. Which means that anybody has to know everything. So people must rely on prices because prices are the information, and provided that they are just conditioning on the same information, they can predict what anybody will do by relying on the same information, which is mathematically good, and basically it is a model of a fair game.
Okay, a question
the problem
here.
is that it doesn't work.
Sorry to cut you off. A question here. But what are the prices that we are talking about here? You are talking about as if a confirmation or a sum of information about the behavior of, if I understand you correctly, some of informations about the behavior of the agents, other agents that we cannot know about them, right? We can talk about the problem of other minds and stuff like that philosophically, but let's forget them. Just economically, we cannot know what they are, what's their intentions and other stuff like that. What would be their behavior? But the price is supposed to be a piece of information about their behavior, and I understand that because the price is supposedly is the residue of the social behavior. But this is a hypothesis. I don't know, and it needs some more, I think, digging. And when you dig, it's not very robust, in my opinion. I'm trying to write.
No, but it's an idealized theory in the sense that it never worked. In the sense that it was the ideal theory, but it never worked. In the sense that the stochastic movement of prices, which is supposed to be the effect, this regularity of stochasticity, never realized, was never there. So we were speculating behind, even when it was supposed to be a stochastic movement of prices. The problem is that if we go on the other side, and when we assume that basically agents are in large words, this means that they don't have all the information which is needed, so they don't know what the other will do. they don't know, they don't share all the information, so they don't even know what the other can do, because they don't know the strategy, because they don't know the preferences, because they don't know which information is used or is considered as pertinent to make choices. So in this situation of a large world, where agents make decisions which are not optimal but are based on information from their surrounding, there are dynamics, as the dynamic which is described by Orleans, which are cascade of information in groups for phenomena of imitation among people connected to the same group, which means that by studying, the people who are studying the dynamic know more than the people who are modelized, because this information is not shared. In classic theory, economic theory is not the privilege of economists. Everybody knows. There is no different of knowledge. In these other models, there is a different of knowledge. So it's based on different of knowledge and of information. So you have agents who are just imitating and don't have information, agents who are autonomous and they have the right information, agents who are making models of the decisions of the other agents. This means that their opinion can be manipulated very easily. So there is something which is more realist, if you want, in the sense that maybe we are in a large world, and where we make our choices, we have not the perfect knowledge which is needed in the equilibrium. But this also means that we are in a situation where there are scientific models about what kind of parameter will make us switch opinion. And I think this is kind of dangerous in some way.
This is a much more accurate depiction of the actual sort of state of affairs now as well, in terms of the ways in which technology is sort of analysing, you know, sentiment and emotion analysis, and then these things tip on the turn of seconds, milliseconds, and you have algorithms that are competing with each other and reading the market, and there's all kinds of very sophisticated modelling that's happening, but also mimetic behaviour at the flip of a switch, you know, the fractions of seconds that change. And you have an entire herd-like behaviour taking down 1% of the market, and it's happened, and then it's corrected itself. But the loss that's been lost has not then been regained on the way up again, and it's incredibly fast. It's beyond human cognition basically now. So it's actually sort of it's a larger than large world, because of its temporality is also at a level of milliseconds.
Yes, of course. Then the prediction of this fluctuation of opinion allows for arbitrage occasions for technological systems, because they detect the parameters, which is just determining a switch of opinion, and they take advantage of this before anybody can realize it.
Yeah. And also gamed, very sophisticated sort of gaming ways of, you know, triggering responses and using the knowledge of the other models that are put, you know, that are set against each other in ways that trigger all sorts of bountiful.
Yeah,
it's fascinating.
Yeah, no, it's fascinating. So, but these possibilities are possibilities which are allowed by the idea that agents are not usually perfectly rational. So in some way, it's less normative, in the sense that we are not imposing agents standards of rationality, which are, and in the same time, we can rationally exploit the impossibility of rational behavior in the others. And I think that this is interesting in the debate between rationality and irrationality of the agents, because agents who are in the condition of not making rational decisions are maybe the person who cannot make optimal decisions but this does not mean that others cannot make more appropriate decisions by knowing more of them. So with these predictive systems and just controlling parameters of change of opinion and information. So in some way, technology is the really rational agent in a market where agents are not in the condition to act as rationally as the machine.
Well, that's interesting, isn't it? Because you've then got the rational agent being performed by the algorithm, but actually it doesn't tend to go that way. There's ways in which that doesn't work out so well either, for the reasons that we were discussing in the Bayesian brain. You know, there are real problems that come up quite short with that. But then you've got the multiplication, you've got the amplification of this, you know, plus the systems that are then reading social media, for example. You know, that's influencing then
yeah, of course,
outcomes in ways that are all about that modeling of sentiment and a degree of belief, the degree of conviction, in fact, that is determining those outcomes, which is super fascinating, because actually that's a real Bayesian, you know, methodology put to purpose, proven to put to purpose in ways that render results in an extraordinary sense, really. Interconnectivities. Anyway.
Yeah, so it's supposed to reduce uncertainty, but it's kind of increasing uncertainty.
Yeah. Yes. What's interesting about the emotion and sentiment analysis aspects of things is that they do drive decisions. There is no question, and it is in action. You know, a very visible, if you like, more partly visible, partly opaque, partly visible way of seeing this conviction, this degree of belief being measured and then given a mathematical signature, and actually then acted upon with modelling that then determines what actions are taken as a result of that, those estimations, that analysis. It's frightening.
So I think that it's time to conclude. So thank you very much to John, Paulina, for the presentation, and to everybody for your participation. And see you next week for the last class.
Bye. Thanks.
Bye. Bye.
Thanks, everyone.